Hi, this is Janagreddy Dubaka. This video is very important for Re-Neet students. In this video, we are going to discuss problems from dual nature of matter and radiation. It is one of the most important topic for NEET students. Here we are expecting at least one or two from this chapter on the concept of de Broglie wavelength and photoelectric effect. See, these are the problems I taken from my book, that is Accelerated Learning Physics Handbook. See, in many NEET papers, questions are directly appeared in NEET exam from this book. Even though there is no change in numericals also, everything is same. Now we are going to discuss some important problems. See here, a particle is dropped from a height h. The de Broglie wavelength of particle as a function of height is proportional to. See here, de Broglie wavelength lambda is equal to h by mv. Therefore, here lambda proportional to 1 by v. When a particle is falling freely from a height h, its velocity after falling through a height v is equal to square root of 2gh. Therefore, here v proportional to root h. Therefore, lambda proportional to 1 by root h. Therefore, lambda proportional to h to the power of minus 1 by 2. Therefore, answer D correct. Next one. An electron is moving with an initial velocity v bar is equal to v naught I cap and is in a magnetic field. V bar is equal to b naught j cap. Then it's a de Broglie wavelength. See, when a particle is moving in a magnetic field, force acting on the charge F bar is equal to Q into V bar cross P bar. This is a magnetic force. See, magnetic force only changes the direction of velocity but does not increase or decrease the speed of the particle. Therefore, here speed V is equal to constant. Therefore, de Broglie wavelength lambda is equal to h by mv. Therefore, here lambda proportional to 1 by v. Here velocity speed constant. Therefore, de Broglie wavelength constant. Therefore, here v constant. Therefore, lambda is equal to constant. De Broglie wavelength remains constant. Next, two particles A1 and A2 of masses M1, M2. Here M1 is greater than M2. Have same de Broglie wavelength. Then here lambda is equal to h by p. Same de Broglie wavelength means momentum constant. Therefore, their momentum are constant. So here energy is equal to p square by 2m. Therefore, momentum constant. Therefore, energy proportional to 1 by m or inversely proportional to mass. As m1 greater than m2, therefore E1 less than E2. Therefore, energy of particle A1 less than energy of particle A2. Therefore, energy of A1 is less than that of energy of A2. Another one, the de Broglie wavelength of photon twice the de Broglie wavelength of electron. So here, de Broglie wavelength of photon twice the de Broglie wavelength of electron. Here, the speed of electron V is equal to C by 100. Then energy of electron by energy of proton. And another option, momentum of electron by me into C, we have to find. First one, wavelength of photon lambda is equal to h by p. Therefore, here h by p is the momentum of photon. Momentum of the photon E by C. That is EP by energy of photon by C. From this, EP is equal to hc by lambda p. That is hc by lambda p is 2 times of de Broglie wavelength of electron. It is equation number 1. Next, energy of electron, that is equal to half mv square, that is half into mass of electron into velocity, means lambda is equal to h by mv. Here v is equal to h by m lambda. Therefore here h by me into lambda e whole square. Therefore this becomes energy of electron is equal to 1 by 2 into me into h square by me square into lambda e square. Therefore here me, 1 me cancel. Then energy of electron is equal to h square by 2 me lambda e square. It is equation number 2. Then 2 divided by 1, that implies energy of electron by energy of photon. Energy of electron is h square by 2 me lambda e square into, this becomes energy of photon, that is hc by 2 lambda e. This becomes 2 lambda e by hc. Therefore here this square h cancel, lambda e 1 lambda e cancel, and 2 cancel. Then energy of electron by energy of photon is equal to, here is he by me into lambda e into c, that is equal to h by me lambda e de Broglie wavelength of electron, that is equal to h by me into e into c. Now this h cancel, me cancel, this becomes ve by c, but ve by c from this equation 10 to the power of minus 2. Therefore energy of electron by energy of photon is equal to 10 to the power of minus 2. Therefore here 10 to the power of minus 2, option B correct. Another one, momentum of electron is equal to mass of electron into ve, that is equal to ve into, but ve is given as c by 100. Therefore c by 100. Therefore pe by me into c, that is equal to 1 by 100, that is 10 to the power of minus 2. pe by mec is equal to 10 to the power of minus 2. Therefore answer c also correct. Here b and c are correct. Next one, consider a metal exposed to light of wavelength 600 nanometer. The maximum kinetic energy of electron double when a light of wavelength 400 nanometer is used. Find the work function. So here when a wavelength is changes from lambda 1 to lambda 2, maximum kinetic energy doubles. So here according to Einstein photoelectric equation, maximum kinetic energy Ke max is equal to hc by lambda 1 work function pi. It is equation number 2. When wavelength changes from lambda 1 to lambda 2, kinetic energy becomes double, means 2 Ke max is equal to, now wavelength is changed from lambda 1 to lambda 2, work function same. Why? Because metal is same. Now from this equation 2 into Ke maximum means hc by lambda 1 minus pi. Therefore hc by lambda 1 minus pi, that is equal to hc by lambda 2 minus pi. This becomes 2 hc by lambda 1 minus 2 pi is equal to hc by lambda 2 minus pi. Therefore here 2 hc by lambda 1 minus hc by lambda 2 is equal to 2 pi minus pi, that is equal to pi. Here hc common, that is 2 by lambda 1 minus 1 by lambda 2 is equal to pi. Therefore pi is equal to hc value in terms of here wavelength is nanometer. Therefore this becomes 1240 electron volt nanometer, that is 2 by lambda 1 is 600 minus 1 by lambda 2 400. After simplification we can get 1.03 electron volts. 1.03 electron volts. Next one, two monochromatic beams A and B of equal intensity I hits a screen. The number of photons hitting the screen by A is twice that by beam B. Then what inference can you make about their frequencies? Means what is the final frequency? See here, intensity I is equal to N into H nu. Here intensity is same, therefore N into nu is equal to constant. This becomes N1 nu1 is equal to N2 nu2. Here I have to discuss about the frequencies. Nu1 by nu2 is equal to N2 by N1. Here uh, number of photons hitting the screen A, that is N1. N1, that is 2 times of B. Therefore N2 I am taking N. N1 is 2N. This becomes 1 by 2. Therefore nu1 by nu2 is equal to 1 by 2, or their frequency ratio nu2 by nu1 is equal to 2 by 1. So depending on the option, we have to decide the answer. Next one. Two particles A and B of de Broglie wavelength lambda 1, lambda 2 combine to form a particle C. The process conserves momentum. Find the de Broglie wavelength of the particle C. See here, when the two particles are moving in same direction according to conservation of momentum, see here in same direction, when they are moving in same direction, momentum of C is equal to momentum of A plus momentum of P. Therefore P is equal to here H by lambda C, that is equal to H by lambda A plus H by lambda B. From this, lambda C is equal to lambda A lambda B by lambda A plus lambda B. This is the wavelength of a particle C when they are moving in same direction. See, for example, in opposite direction, means they are moving in opposite direction. Therefore, momentum of C is equal to momentum of A minus momentum of B. This becomes H by lambda C is equal to H by lambda A minus H by lambda B. From this, lambda C is equal to lambda A into lambda B modulus of lambda A minus lambda B. We don't know which one is a larger one. Therefore, this is the de Broglie wavelength of particle C when they are moving in opposite directions. Next one. An electron of mass m with de Broglie wavelength lambda fall on the target in X-ray tube. The cutoff wavelength lambda naught of emitted X-rays. See here, the kinetic energy of electrons, that is equal to P square by 2m. Here P is the momentum of electron. In terms of de Broglie wavelength, P is equal to h by lambda whole square by 2m. Therefore, kinetic energy is equal to h square by 2m lambda square. This is the kinetic energy of electron. Therefore, this kinetic energy of electrons, when it is a target in X-ray tube, this total energy, kinetic energy transferred to photon. Therefore, photon energy h nu is equal to kinetic energy of electron. This h nu we can write down hc by lambda. Here lambda means nothing but cutoff wavelength lambda naught. That is equal to kinetic energy h square by 2m lambda square. See here h, 1h cancel. Therefore, lambda naught is equal to 2m lambda square c by h. Therefore, answer A correct. Next one. Here a photoelectric surface is illuminated successively by a monochromatic light of wavelength lambda, and here is lambda by 2. If the maximum kinetic energy of the emitted photoelectrons in the second case is 3 times that in the first case, the work function of the surface of the metal is. In first case, maximum kinetic energy Ke max is equal to hc by lambda minus pi. It is equation number 1. When wavelength changes from lambda to lambda by 2, kinetic energy 3 times of initial kinetic energy. Therefore, that is equal to hc by lambda by 2 minus pi. Therefore, 3 into Ke max means hc by lambda minus pi, that is equal to 2 hc by lambda minus pi. Therefore, from this 3 hc by lambda minus 3 pi is equal to 2 hc lambda minus pi. See here, when 2 hc by lambda come this side, this becomes minus 2 hc by lambda. This is 3 hc by lambda. Therefore, 3 hc by lambda minus 2 hc by lambda, that is hc by lambda. That is equal to this 3 pi comes this side plus 3 pi. Therefore, this becomes 3 pi minus pi, that is 2 pi. Therefore, pi is equal to hc by 2 lambda. Pi is equal to hc by 2 lambda. Answer C correct. Next one. Here, when the energy of incident radiation is increased by 20%, the kinetic energy of photoelectrons emitted from the metal surface increased from 0.5 electron volt to 0.8 electron volts. The work function of the metal is. See here, initial kinetic energy is 0.85. See 0.5 electron volts is equal to incident energy I am taking E, and work function is pi. And when this kinetic energy changes to 0.8 eV, when incident energy increases by 20%, means this becomes 1 point E minus pi. It is equation number 1. Equation number 2. So when you subtract 2 minus 1, that implies 0.8 minus 0.5, that is 1 point E minus pi minus E plus pi. Therefore, this minus plus cancel. 0.8 minus 0.5, 0.5. This is 1 point E minus E, 0 point E, 0 point E. Therefore, E is equal to 0.5 by 0.2, that is 5 by 2. Therefore, 2.5. So, when this E substitute in equation 1 or equation 2, we can get pi. That pi is equal to approximately 1 electron volt. Next one. For a photoelectric emission from certain metal, the cutoff frequency is nu, means threshold frequency is nu. If radiation of frequency 2 nu impinging on the metal plate, the maximum possible velocity of the emitted electrons. See, maximum kinetic energy in terms of velocity of mv square, that is equal to incident energy. Here, incident radiation frequency 2 nu, therefore h into 2 nu. Work function h nu naught. Therefore, of mv square is equal to 2h nu minus threshold frequency is given as h nu, that is equal to h nu. Therefore, v square is equal to 2h nu by m. Therefore, v is equal to square root of 2h nu by m. This is the velocity of emitted photoelectrons. Next one. If the momentum of electron is changed by p, then the de Broglie wavelength associated with it changes by 0.5%. The initial momentum of electron is. See here, lambda is equal to h by p. Therefore, delta lambda by lambda is equal to minus delta p by p. If you consider only magnitude, that is delta p by p. Here it is given as percentage change in wavelength. Delta lambda by lambda into 100 is equal to 0.5. Therefore, delta lambda by lambda is equal to 0.5 by 100. Therefore, this becomes 0.5 by 100. Delta P, change in momentum, is given as P. Here, this P I am taking P initial. Therefore, here P initial is equal to 100 P by 0.5. Therefore, P initial is equal to 1000 P by 5. Therefore, P initial is equal to 200 P. This is the initial momentum, 200 P. Next one. A photocell is illuminated by a small bright source placed 1 meter away. When the same source of light is placed 1 by 2 meter away, the number of electrons emitted by photocathode will be. See here, this is a source P at a distance D, intensity I. That intensity is equal to P by 4 pi D square. Therefore, intensity proportional to 1 by D square. This intensity means number of electrons per second. Therefore, that number of electrons are I1 by I2 is equal to D2 by D1 whole square. D2 is given as 1 by 2. This is 1 whole square. That is 1 by 4. Therefore, I2 is equal to 4I1. Therefore, number of electrons emitted by a photocathode 4 times the initial value. Next one. This is very important one. The de Broglie wavelength lambda b associated with electron orbiting in second excited state of hydrogen atom is related to that in ground state. So here lambda is equal to h by mv. This is de Broglie wavelength. But velocity in nth orbit v proportional to z by n. Therefore, here lambda proportional to v proportional to z by n. Therefore, lambda proportional to n. Therefore, lambda 1 by lambda 2 is equal to n1 by n2. De Broglie wavelength associated with the second excited state, that is lambda b, and ground state lambda g. Second excited state means n is equal to 3 and ground state means 1. Therefore, lambda b is equal to 3 lambda g. Therefore, answer A correct. Next one. Photon of wavelength lambda emitted by a source of power P incident on a photocell if the current produced in the cell is I. The percentage of incident photons which produce the current in a photocell is. For example, this is a source of power P. From this, photons are incidents on a photocell. From this photocell, electrons are emitted. See here, number of photons incident on a photocell, that is rate of photon flux or rate of photon, number of photons emitted per second, that is Np, that is equal to P lambda by Hc. Here, electrons are emitted from the photocell. Due to this electron, photoelectric current I is equal to Ne by T. From this, N by T is equal to I by E. This number of electrons emitted per second, that is photoelectric current, I am taking Ne, that is equal to I by E. Here, percentage of incident photons which produce current, that is Ne by Np into 100. That is I by E by Np means Hc by P lambda into 100. This becomes 100 IHc by P lambda E. This is answer. 100 IHc by EP lambda. EP P lambda E. That is answer D correct. Next one. A photon of energy E emits a photoelectron from a metal surface where work function is W naught. If this electron enters a uniform magnetic field B in a direction perpendicular to the field and describe a circle of radius R, then R is. So here whenever a charge is moving or enter into a magnetic field which is perpendicular to the magnetic field, charge describes in a circular path. Then the radius of the circular path R is equal to mv by bq. But from Einstein photoelectric equation, maximum kinetic energy of mv square is equal to photon energy E minus work function W naught. From this, V square is equal to 2 into E minus W naught by M. Therefore, V is equal to square root of 2 into E minus W naught by M. And this we want to substitute in this equation. Therefore, R is equal to M by BQ into square root of 2 into E minus W naught by M. See, when this M is taken into the root, it becomes M square. Here is M square, this is M, 1 M cancel. Therefore, R is equal to 1 by BQ into square root of 2M E minus W naught. Therefore, this is answer. Answer D is correct. Next one. Light of frequency 4 into 10 to the power 14 Hz is incident on a metal surface of work function 2.14 electron volt meter. The resulting in photo emission, not electron volt, work function is 2.14 electron volt. Resulting photo emission of electrons. The maximum kinetic energy of emitted electrons. See, first we have to check whether the electrons are emitted, means photoelectric effect takes place or not. This is possible when incident photon energy greater than work function, then only electrons are emitted. First we have to find out incident energy, that is E is equal to h nu. H is 6.63 into 10 to the power of minus 34. Frequency is given as 4 into 10 to the power of 14. This energy becomes 1.65 electron volts, but work function is 2.14 electron volts. Here, incident energy less than the work function, therefore, there is no photoelectric emission takes place. Therefore, no photoelectric emission means there is no photoelectric emission means no photoelectrons are emitted. Therefore, velocity is equal to 0. This is already we did this problem. This is a repeated one. Answer is hc by 2 lambda. Next one. Next one. The de Broglie wavelength associated with electron in n is equal to 4 level is. So here lambda is equal to h by mv. V proportional to 1 by n. Therefore, lambda proportional to n. Therefore, lambda 1 by lambda 2 is equal to n1 by n2. Lambda 1 by lambda 2. n1 is ground level and n2 is equal to 4. That is 1 by 4. Lambda 2 is equal to 4 lambda 1. This is 4 times of de Broglie wavelength in ground level. Therefore, answer is 4 times de Broglie wavelength of electron in ground state. Next one. In a photoelectric effect experiment, collector plate is placed vertically above the emitter plate. Light is allowed to incident on an emitter and a saturation photocurrent records. Now, parallel electric and magnetic fields are applied vertically downwards between the plates. Then photo current will increase. The kinetic energy of photoelectrons will decrease the stopping potential will increase, the threshold wavelength will increase. See here, this is the cathode, this is the emitter. Here electrons are emitted from the emitter and moving towards the collector. Here we are applying electric field and magnetic field in vertical direction. Here magnetic field is parallel or anti-parallel to motion of the charge. There is no magnetic force. But there is a force due to electric field. That force due to electric field for a negative charge, it is opposite to the field direction. Therefore, field is in downward direction. Force due to electric field is in upward direction. Due to this force and the velocity of the or kinetic energy of the electrons increases. As kinetic energy increases, maximum kinetic energy of electrons increases, this becomes EV naught. Therefore, stopping potential also increases. Therefore, the stopping potential will increase. Next one. An alpha particle moves in a circular path of radius 1 centimeter in uniform magnetic field 0.125 Tesla. The de Broglie wavelength associated with alpha particle. When alpha particle moving in a circular path in a magnetic field, radius r is equal to mv by bq. Then de Broglie wavelength lambda is equal to h by mv. Therefore, lambda is equal to h by mv means mv is equal to bqr. Therefore, this becomes bqr. Therefore, lambda is equal to h 6.6 into 10 to the power of minus 34 and b is given as 0.125. Charge of alpha particle is 2 times of electron 1.6 into 10 to the power of minus 19 and radius is given as 1 centimeter, that is 1 into 10 to the power of minus 2. After simplification we can get 1.65 into 10 to the power of minus 12 meters. Next one. A photodiode sensor is used to measure the output of a 300-watt lamp kept 10 meter away. The sensor has an opening of 2 centimeter in diameter. How many photons enter the sensor if the wavelength of light is 660 nanometer and exposure time is 100 millisecond? First one. This is a light source of power P. From this light source at a distance t, here is the sensor. Therefore, intensity at this sensor I is equal to P by 4 pi d square. Here this intensity means energy received by this sensor per unit area in unit time. That is nothing but E by A into T. Therefore, P by 4 pi d square. This energy means how many number of photons are emitted or receiving by this sensor. That I am taking N h nu. H nu means C by lambda. A means area of the sensor pi r square into T, that is P by 4 pi d square. Therefore, N into this here Hc by lambda. This Hc by lambda is nothing but 12,000. Wavelength is nanometer 1240. Electron volt nanometer. Therefore, electron volt means 1.6 into 10 to the power of minus 19. Here is this is N into N by this pi gets cancelled. R is a radius, that is given as diameter 2 centimeter. 1 into 10 to the power of minus 2 whole square into T 100 millisecond. Therefore, 100 into 10 to the power of minus 3 and power is given as 300 watts by 4 into distance is 10 meter. Therefore, 10 square 100. After this by simplification we can get number of photons received 2.5 into 10 cube. n is equal to 2.5 into n cube. Next one. A photon of wavelength lambda is scattered from electron which was at rest. The wavelength shift delta lambda is 3 times of lambda, and the angle of scattering theta is 60 degrees. The angle at which the electron recoiled is pi. The value of tan pi is. See here, this is the photon. This photon momentum p is equal to h by lambda. Here is the electron which is at rest. After collision, this photon recoiled in this direction with an angle 60 degrees, wavelength lambda dash. And the electron is recoiled. This is the electron, mass m, moving with velocity v, and this angle is pi. This lambda dash is equal to lambda plus delta lambda. Delta lambda is given as 3 lambda. Therefore, this becomes 4 lambda. Here we have to conserve momentum in x direction and y direction. See, initial momentum along x direction is equal to final momentum along x direction. Initially, electron is at rest, only the momentum of photon, that is p is equal to h by lambda. This becomes h by lambda, that is equal to momentum of scattered photon in x direction. This is 4 lambda cos 60. Therefore, here momentum means h by 4 lambda. H by 4 lambda cos 60, and momentum of electron plus h by mv plus h by mv cos pi. It is equation number 1. Next one. Momentum, initial momentum along y direction, final momentum along y direction. Initially, there is no momentum along y direction. This is 0. After that, momentum of scattered photon in this direction, h by 4 lambda sin 60. Therefore, h by 4 lambda sin 60, and this one electron in this direction downwards minus. Therefore, minus h by mv sin pi. It is equation number 2. See, from these equations 1 and 2, we can directly find out tan pi is equal to root 3 by 7. Tan pi is equal to root 3 by 7. Next one. See here, this is also very important one. If one were to apply Bohr's model to a particle of mass m and a charge q moving in a plane under the influence of magnetic field B, the energy of charged particle in nth level, energy of particle in nth level. See here, in a uniform magnetic field, radius r is equal to mv by bq. When Bohr's model is applied, angular momentum mvr is equal to nh by 2 pi. This is equation number 1. It is equation number 2. See here, mv into r, 1 minute. From this, r is equal to nh by 2 pi mv. Here r is equal to mv by bq. mv by bq is equal to nh by 2 pi mv. Then, see here, when this v comes here, mv square. Therefore, mv square is equal to bq nh by 2 pi m. 2 pi m. This is mv square. But we have to find out the energy of charged particle in nth level. Energy of particle in nth level is total energy. But total energy is equal to magnitude of kinetic energy. That kinetic energy is equal to half mv square. Therefore, total energy is equal to half into mv square is equal to this one. That is bq by 2 pi m. Therefore, this total energy is equal to bq by 4 pi m. This is the total energy. Next one. This is also very, very important. If the de Broglie wavelength associated with a proton and alpha particles are equal, then the ratio of velocities of proton and alpha particle, here lambda is equal to h by mv. The de Broglie wavelength associated proton and alpha particle are equal, h is same, lambda same. Therefore, m into v is equal to constant. This becomes then the ratio of velocities of proton and velocity of proton are here v proportional to 1 by m. Therefore, velocity of proton to velocity of alpha particle, that is equal to mass of alpha particle by mass of proton. See, proton means 1h1, alpha means He24. Therefore, these two are mass numbers. Therefore, velocity of proton by velocity of alpha. Mass of alpha is equal to 4 units. Mass of proton is equal to 1. Therefore, velocity of proton by velocity of alpha is equal to 4 is to 1. See, these are the problems from dual nature of matter and radiation. So, very, 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 very important.